Hello friends, today we are going to study electrostatic potential. In electrostatic potential, electrostatic potential. Under this topic, so far we have studied line integral of electric field. अभी तक हमने पढ़ा है line integral of electric field and what is that? This is your initial position, this is your final position PF and vector E dot vector dl. This is your line integral of electric field. And what is the value of line integral of electric field is we have studied that 1 by 4 pi epsilon naught q 1 by Ri minus 1 by Rf. This is your line integral of electric field. We had studied in the last class. हमने पिछली क्लास में पढ़ा था ये line integral of electric field है. So if we consider this equation, what we find that what is this? This is line integral of electric field. This is in this electric field is a force. What is electric field? And also in this formula for PF, this is your position vector. Position vector of point, final point is your RF, and position vector of initial point is your Ri. Here Ri is the position vector of initial point and Rf is your final position vector of final point. So this is your line integral and we had studied in the last class. हमने पिछली क्लास में इसके बारे में पढ़ा था. Now what is your electric field? Electric field is your actually a force. Force on unit positive test charge. So electric field is what? Force on unit positive test charge. Which type of force? Electrostatic force. This is electrostatic force on unit positive test charge. This is your electric field. And dl is your small displacement. And you know that our work done, what is your work done? Work done by a force is your formula is your what? Vector E, vector P, sorry, vector F dot dr is your work done by the force F. So this is actually work done by the electric field. So line integral of electric field is actually work done by the electric field from initial position Pi to final position Pf. We had studied this in the last class. हमने पिछली क्लास में पढ़ा था लाइन इंटीग्रल एक्चुअली में क्या है, वर्क डन है इनिशियल पोजीशन से फाइनल पोजीशन तक का. क्योंकि जो वर्क डन बाय अ फोर्स का फॉर्मूला ये है, हम लोग जानते हैं 11th क्लास वर्क डन से, वर्क डन का ये है फॉर्मूला. सो दिस इज सिमिलर टू वर्क डन, यह वर्क डन के सिमिलर है. So electric field, line integral of electric field is your work done by the electric field on unit positive test charge. So here we can write that this is actually this that we have studied this is actually equal to work done by electric field in moving a unit positive test charge from point Pi, whose position vector is your Ri, to point Pf, final position, whose position vector is your Rf. So this line integral of electric field, which is equal to this, is actually work done by the electric field in moving a unit positive test charge from point Pi to point Pf, because this electric field is your force on unit positive test charge. So basically this is your work done by the electric field in moving unit positive test charge from initial position to final position. So this was your line integral. Now come to the electrostatic potential. What is before that we before studying electrostatic potential, we understand what is your actually potential. Before studying electrostatic potential, first we try to know what is your potential. What is potential difference? Potential difference. Potential difference. So potential difference is defined when we have conservative force working. If there is no conservative force, then there will be no potential difference, or we also say it as potential energy difference. Potential energy difference or potential difference. So potential difference is actually is equal to, or we work done is work done against a conservative force by external force. A conservative force work done against conservative force by external force, or we can say that negative of work done by conservative force. So here potential difference, what is potential difference, is actually work done against conservative force. Most important thing is here conservative force. If there is no conservative force, means we cannot have potential energy difference. There will be no difference in potential energy. Potential energy of the system will remain as it is. There will be no change in potential difference if there is no conservative force, because the potential energy difference is actually work done against a conservative force. So there must be a conservative force, one thing, and the other thing is there must be work done against conservative force. So who will do the work? Work will do the external agency, external force. Any external agency or external force may be the factor which factor will work against the conservative force. This thing can be represented in another way, that because here it is work done against conservative force, so we can write this in the same way, in a different manner, that it is negative of the work done by the conservative force. Is the same thing. Work done against a conservative force is equal to negative of the work done by the conservative force. So for calculative purpose, for calculation, it is easier sometimes, we feel easier to solve the question by taking this as, because if conservative force is known, we can easily find the negative of this, but if conservative force is not known, so this will be helpful. But either of the two will be helpful in different context, भिन्न भिन्न अवस्थाओं में, भिन्न भिन्न सिचुएशन में दोनों ही हमें मददगार होंगे। ये यहाँ से हमें ये पता चलता है कि यह क्या है, वर्क डन अगेंस्ट कंजर्वेटिव फोर्स है। और यहाँ से क्या पता चलता है, यह नेगेटिव ऑफ द वर्क डन बाय द कंजर्वेटिव फोर्स है। So this will be your potential difference. Now, according to the name of the conservative force, the name is given to this potential difference. So likewise, we study gravitational potential difference. If this conservative force is your gravitational force, if this conservative force is your gravitational force, then it will be, if conservative force is gravitational force, then the name will be what? Gravitational potential difference. But if the force gravitational, if the conservative force becomes your electrostatic force, if your conservative force is your electrostatic force, the name will change and its name will be electrostatic potential difference. Means your potential difference is electrostatic potential difference if conservative force is your electrostatic force, for example Coulomb's force or electric field, and if the conservative force is your gravitational force, then its name becomes gravitational potential energy difference or gravitational potential difference. So this gravitational potential difference we study in 11th class, and this electrostatic potential difference we study in 12th class. But there is no difference, because just like gravitational force, we have here electrostatic force, that is electric field. जैसे वहाँ हमने ग्रेविटेशनल फोर्स पढ़ा था, वैसे ही यहाँ पे हम इलेक्ट्रोस्टैटिक फोर्स पढ़ते हैं, है ना। जब इस कंजर्वेटिव फोर्स का नाम इलेक्ट्रोस्टैटिक हो, जब इस कंजर्वेटिव फोर्स में हम लोग ग्रेविटेशनल फोर्स को लेते हैं, यानी कंजर्वेटिव फोर्स जब ग्रेविटेशनल फोर्स होता है तो इसका नाम हो जाता है ग्रेविटेशनल पोटेंशियल डिफरेंस, जो कि हमने 11th क्लास में पढ़ा है। और जब कंजर्वेटिव फोर्स इलेक्ट्रोस्टैटिक फोर्स काम करता है तो उसका नाम हो जाता है इलेक्ट्रोस्टैटिक पोटेंशियल डिफरेंस, जो कि हम लोग अभी पढ़ रहे हैं। सो इलेक्ट्रोस्टैटिक पोटेंशियल डिफरेंस का मतलब क्या हुआ, वो हम लोग लिख सकते हैं इन वन वे। तो ये है पोटेंशियल डिफरेंस। नाउ बात आती है कि यदि हमें कहा जाए इलेक्ट्रोस्टैटिक पोटेंशियल डिफरेंस, पोटेंशियल डिफरेंस, तो ये क्या होगा, ये क्या होगा, ये होगा नेगेटिव ऑफ द वर्क डन बाय द electric field, work done by the negative of the work done by the electric field, because what is your electric field is your work done by the electric field, negative of the work done by the electric field. So, and what is the work done by the electric field? It is the line integral. So we can say negative of the line integral of electric field, or we can also write work done against electric field by external force. All these are same thing. By either of the ways you can calculate negative of the work done by the electric field, or negative of the line integral of electric field, or work done against the electric field by external force. So we take this this negative of the line integral of electric field as the electrostatic potential difference. So now we have understood that what is actually electrostatic potential difference. It is actually negative of the line integral of electric field. Now what is line integral? We know negative and r p I initial position, pf is vector E dot dl. This is your line integral of electric field from point Pi to Pf. So this is your what? Electrostatic potential difference. We represent it V Pi initial position to V Pf final position, and we say that what is this? Final position potential minus initial position potential, because it is potential difference. So V Pi Pf minus final minus initial, and this is equal to, we know that, negative minus 1 by 4 pi epsilon naught Q R I minus R F, where Ri and Rf are position vectors of Pi and Pf. So this will be 1 by 4 pi epsilon naught Q into 1 by Rf minus 1 by Ri. This is your negative of the line integral, or this is negative of the work done by the electric field, or this is your electrostatic potential difference from point Pf, from point Pi to Pf, or between Pf and Pi. So we can write it as electrostatic potential difference means initial to final point is your Vpf minus Vpi, and is actually equal to 1 by 4 pi epsilon naught Q 1 by Rf minus 1 by Ri. This is your actually the formula, and this is your electrostatic potential difference. So here we understood that what is electrostatic potential difference. And if we represent it in the diagram, we can draw the diagram like this. This is origin, this is x-axis, this is your y-axis. Suppose here it is like this. This is your initial position pi, this is your final position pf, and this is its ri position vector, and this is rf position vector, and here a point charge plus q is situated at the origin. So in that case, what will be the electrostatic potential difference between pi and pf will be this vpf pi will be vpi pf, and it will be final minus initial, and it will be equal to 1 by 4 pi epsilon naught q into 1 by rf minus 1 by r. So this is your electrostatic potential difference formula, and this is your diagram to understand how this formula is working. So you have got the point that if we have to calculate electrostatic potential difference between pi and pf, so we can represent. And where is your electric field? So you can represent, here is your electric field at this point E1 suppose, and at this point electric field is your like this E2. So this is your electric field, and by this method you can represent. So this was your electrostatic potential difference. Thank you very much. The remaining things will be covered in the next class. Thank you.